Part D, work out the area of the triangle ABC. So work out the area from A to B to C. So we want to figure out the area of the space inside this triangle. Okay, so the area of a triangle formula is found on page 9 of our formula book. And it says A equals half AH. The capital A represents area. The small a represents the base of the triangle, so that's the bottom part of the triangle, the base of the triangle. And the h represents the perpendicular height. So that's the height of the triangle. So the perpendicular height means the height where it meets a T-junction. So if you imagine that this red line being the base and this red line being the height, we can see that those two lines meet at a T-junction. So this is like an upside down capital T. And that means that it meets at a perpendicular. So it forms a right angle on either side. So this is a 90-degree right angle, and this is also a 90-degree right angle. So don't get mixed up with the height, because sometimes people think that this part here would be the height. This would technically be the slant height, or this part here. But when we're interested in the area of a triangle, we're interested in the perpendicular height. So it's where it meets the base at a T-junction. That's like an upside down capital T. So A equals a half AH. A half, A and H are all stuck together. And anything stuck together in maths means multiply. So it means a half multiplied by A multiplied by H. So it means a half multiplied by the base multiplied by the perpendicular height. So we need to figure out, well, what is the base first of all? And we can see from C to A, it is a distance of 4 units. So 1, 2, 3, 4 units. So we're going to swap the A for 4 with brackets around it. Very important that when we do substitution, we always swap a letter for brackets and then we put the number inside the brackets. So the A, which represents the base, is 4 units across, so we put 4 with brackets around it. Then the H, representing the perpendicular height. We can see from here to here is a height of 3 units. So we've got 1, 2, 3 units. So we swap the H for 3, again with brackets around it. And brackets mean multiply. And 4 multiplied by 3 is 12. And half of 12 is 6. So you get 6 units squared. It has to be squared because it's area. Now if we had done this without brackets, we would have been getting half of 43, which would be incorrect. So half times base times height, half times 4 times 3 is 6 units squared. So the area of the triangle ABC is 6 units squared. Part E. On the coordinate diagram, draw the image of the triangle ABC under central symmetry in the point D. So this is our triangle ABC, and we want to draw the image of it under central symmetry in the point D. So this is the point D, and we want to draw the image of this triangle under central symmetry in this point D. Okay, so for this question, we're going to need to use our ruler and a pencil. And we choose a starting point. I'm going to start with point A. And we get our ruler and we line it up with point A and point D. So what we want to do is reflect our shape under central symmetry in the point D. So we start with point A. We can start with any point we want, but I'm going to go alphabetically and start with point A. And we line up point A with point D. And what we want to do is reflect point A in point D. So I line up my ruler with point A and point D, and I see I have 2 steps, or a distance of 2 units, to get from point A to point D. So I go in the opposite direction, another 2 units, and I put a point. So I lined up my ruler with point A and point D, and to get from A to D, it was a distance of 2 boxes, or 2 units. So I'm going to go in the opposite direction, another distance of 2 boxes or 2 units, and put a point. So I've reflected A in D. So then I'm going to go with point B, and I'm going to do the same thing. I'm going to line up point B with my ruler. Now I can't see for definite exactly how many boxes I've gone through. I can see diagonally I've gone through 2 boxes, but it might be difficult to see. So it might be best to actually just measure with your ruler how many centimeters you have gone from point B to point D. And you do the same in the opposite direction, and you put your new point at the end of that line. So I lined up my ruler with point B and point D, and whatever distance I use to get from B to D, I continue on in the opposite direction and put a point. And now I'm going to reflect C through D. So again, I line up my ruler with point C and point D, and I can see that I'm going diagonally through 1, 2, 3, 4 boxes. But again, it might be difficult to see, so it might be best just to measure with a ruler the actual distance in centimeters. Either way, I line up my ruler with point C and point D, and I go the same distance on the other side, and I put a point. So my triangle had 3 points to begin with, A, B and C, and my new triangle has 3 points, so I just join them together with a ruler, and then I have the reflection of the original triangle through point D.